Okay, so very good morning to Dr. Mark Lastly. My name is Lau Chun Hei, and I'll be representing my group, which is Group 3 for this project presentation for the subject Microprocessor BLC 3543. And the topic we chose is Digital Water Level Monitoring System. So here you can see our code written in IDE 68K, and here I'll demonstrate the program. So first of all, we have our hardware definitions and our variables declaration. So for hardware definitions, the level in is the slider, which acts as the water level input, and the LEDs acts as the output to display the LED for different situations. Then the switches is for us to select different modes. In our case, we only use switch number 0 and switch number 1. Then we have the bar display to display the water level from our input. Here will be our output. Then we have our blink flag and delay value as our variables. So the blink flag will be used as a toggle flag for us to use in our blinking function later. Then we have our delay value for us to set the delay speed. Then we'll start off by setting our status register in 2700. So the 00 will be indicating that the lower byte of the status register, which is the CCR, it will be set to 0 to disable the CCR. Then 7, which is in hexadecimal, is 0111, which is in the status register. It will be located at bit number 8 to 10. We will set the bit number 8 to bit number 10 to 1. This will disable all the interrupt masks. And the 2 here in hexadecimal is 0010, which will be located in the upper byte in the status register. So the bit number 13 will be set to 1. And the bit number 13 is the supervisor bit. So when we set that to 1, we will be able to use the supervisor mode here. Then we go to the next line where we set our LED number 6 to switch on, which is the water inlet valve. So here indicating that our water inlet valve is switched on. And we set our blink flag and delay value to 0. We clear them. Then we go into our main loop where we read our water level from the slider. So let's say our water level is set here. And then we show to our bar display and also put them into D0. Then we're going to test our switch to see which mode are we using. So for now, we're going to let it be normal mode, where the switch number 1 is not on. So we're going to go into normal mode. In normal mode, we're going to compare our water level and see which category did we goes in. So first we're going to compare our water level to 13, which is 5% of the total value. So for the slider, total value will be 256 bit, and 5% of that will be 13. So we will compare if it is lesser than 13 or not. Then if it is lesser, then it's critically low. We're going to branch into the critical low. If it is lesser than 15%, it means that lesser than 39. We're going to branch into the low level category. If it is more than 50%, which means more than 128 bit, then we're going to branch into high level. So for now, let's go through, and we went into the low level. We went into the low level, meaning that we are more than 5% and less than 15%. So in low level, we're gonna set our LED 0 to on, and our LED 6 is still on because the water inlet valve is still on, and we're gonna branch into do delay. So in do delay, it's a function where we keep the function going. So in do delay, we can choose between 2 speed, which is a faster speed or a low speed. But since in this case the LED is just switching on, so it doesn't matter if the speed is fast or slow. I'm going to go do delay, and in this case we're going to test for the switch number 0 and see if it's switched on. So in this case, the switch is not on, meaning that we're going to branch into short delay. So in short delay, we're going to set our D2 into 10, which is a small value compared to FFFF, which is a large value. So for a short value, meaning the loop will go faster. Because in the delay loop later, we have to subtract 1 from the value here, and until it reaches 0. So if you subtract 1 from 10, it is faster to reach 0 than compared to subtracting it from FFFF. When you want to reach 0, you have to go through a long loop. So for now, we go into short delay. We set D2 into 10, and we minus 1. You can see our D2 is minus 1 until it reaches 0. Then we're going to branch back into main loop. So in main loop, we're going to do everything again. So for now, let's say we set our slider into less than 5%. We're going to go. Our test mode is still not on, still in our normal mode now. Then here they're going to jump into critical low. We're going to branch to critical low since it is less than 5%. In critical low function here, we will update our blink flag, which is here. We're going to branch into our update blink flag. Then we're going to set our blink flag into 1 because earlier it was 0. Now using exclusive or immediate, we're going to set to 1 and return back to subroutine. And we test our blink flag, which is 1. Since it is 1, we're not going into this branch, crit off. And we're going to go to the next line, and the LED number 0 and LED 6 will be switched on. 0 and 6 will be switched on, and go back to do delay. And the delay goes the same until it reaches 0. And we go back to main loop. So since our level is less than 5%, we want to set the LED to blinking situation, right? So earlier the LED were switched on. Now when you go back to the loop again, you're going to go back into the critical low function here. But here, when you update the blink flag, it's going to become 0 instead of 1, because earlier was 1. So now using exclusive or immediate, we're going to change back to 0 and return back to subroutine. And we check our blink flag. So now it's 0. We're going to execute our next line, which is the branch into crit off. And we go to crit off, we set our LED to off, and branch to delay again. So you can see within these two loops, our LED were set to on and off, so indicating that the LED will blink. So if I let the code to run, it will blink. And let's say if we go water level more than 15%, so this is more than 5%, the LEDs are not blinking in stable mode. So the water inlet is still switching on, and the LED 0 switching on, indicating that the water level is more than 5% but less than 15%. So once you reaches 15% above, you get LED 1 on, and if you go more than 50%, LED 2 will be on, but LED 6 will be off because the water inlet valve is off. So if we use the test mode, which is the switch number 1, you will see that 3 of these LED will blink. And you use the switch number 0 to set the delay speed. You can see the speed will be different, because when switch 0 is on, you will not go into short delay. Instead, you will get FFFF into D2, which is a large value to subtract 1 by 1. So we're going to go into the loop slower. Yeah, and that's all for our program. Yes, that's all for our program, and thank you for listening.